All right, let's dive in and tackle one of the most powerful and, let's be honest, often confusing tools in algebra, logarithms. I promise, by the end of this, we're going to transform them from a puzzle into a simple, elegant key that you can use with total confidence. Have you ever looked at an equation with log in it and just felt like you were trying to read a completely different language? Well, you're not alone. And actually, you know what? That's the perfect way to think about it. So for the next few minutes, let's just run with that idea. Logarithmic form and exponential form are just two different languages saying the exact same thing.
And that right there, that is the secret. The single most important skill you need isn't about memorizing a ton of rules, it's about becoming a fluent translator. Once you can switch between these two forms, just back and forth effortlessly, you've pretty much unlocked the whole concept.
So, how do we translate? Well, every language has rules, right? A grammar. For us, our grammar is a formula. You can think of it like our Rosetta Stone, the key that's going to unlock the meaning and let us move between these two mathematical languages.
And here it is. On the left, we've got our logarithmic form, log base b of x equals y. And on the right, the exponential form, b to the power of y equals x. Take a good look. Do you see it? They're not different ideas. They're just different arrangements of the exact same three pieces.
So let's break down those pieces really quick. B is our base. That's the foundation of the whole thing. Y is the exponent, which is the power we're raising that base to. And x is simply the result, what you get after you do the math. Their positions might move around when we translate, but their jobs stay exactly the same. The base is always the base.
Okay, enough with the theory. The best way to learn any language is to actually start speaking it, right? So let's put this conversion code to work and translate some real examples.
So let's start with this one. Log base 5 of 125 equals 3. First thing we do is identify our parts. The base, b, is 5, the result, x, is 125, and the answer to the log, y, is 3. Now we just rearrange them into our exponential format, which is b to the y equals x, and boom, 5 to the power of 3 equals 125. See? It's the exact same statement, just written in a different language.
Now let's try going the other way. We've got 10 to the power of negative 2 equals 0.01. It is the exact same process. Our base is 10, our exponent is negative 2, and our result is 0.01. We just slot those pieces into our log format, and what we get is log base 10 of 0.01 equals negative 2. It's a perfect two-way street.
So, why is this translation skill so incredibly useful? Because it is a powerful problem-solving tool. Check this out. Solve for x in log base 3 of x equals 4. Looking at it like this, it's not super obvious what x is. But what happens if we translate it? Our base is 3, our exponent is 4, and the result is x. That gives us 3 to the power of 4 equals x. All of a sudden, that's a super easy calculation. 3 times 3 is 9, times 3 is 27, times 3 is 81. So x equals 81. The translation just handed us the answer.
Now, just like learning any new language, there are a few common trip-ups, let's call them mistranslations, that pretty much everyone makes when they're starting out. But here's the good news. They are incredibly predictable, which means they are really easy to avoid once you know what to look for.
This right here is the number one error, mixing up the base and the result. People see log base b of x equals y, and they'll incorrectly write x to the power of y equals b. Just burn this into your brain. The base of the logarithm, that little subscript number, is always the base of the exponent. It's the number that gets the power, period.
And this leads us to the single most important definition of all. Seriously, the answer to a logarithm is always the exponent, always. When you see an expression like log base 2 of 8, the question it's secretly asking you is this: what exponent do I need to put on 2 to get 8? And the answer, of course, is 3.
Okay, so you can translate back and forth. Great. But why does this actually matter beyond your next algebra test? Well, it matters because this skill is a fundamental bridge used in all sorts of scientific and financial problem solving.
Think about it this way. Exponential equations are great for answering questions like, how much will I have after a certain amount of time? You know, like, if this investment grows by 5% a year, how much will I have in 10 years? You're solving for the final amount. But logarithms, they answer the opposite question. How long will it take to get to a certain amount? Like, how long will it take for my investment to double? Now you're solving for the exponent, which is usually time. That's a logarithm question. And translation is how we switch between those two big ideas.
So, we've seen that mastering logarithms isn't about memorizing some complex alien formula. It's really just about learning to be a translator. It's about seeing that 2 to the third equals 8 and log 2 of 8 equals 3 are just two different ways of saying the exact same beautiful mathematical truth. So I'll leave you at this. Now that you have the key to translation, what new problems, what new questions can you unlock and solve?